So yesterday we kind of talked about using tables to do it. Again, a double number line is just another way to help you. So if after this lesson today you're like, double number lines are not going to be the best strategy for me, that is fine. Remember, it is just a strategy. It is not something that you have to do. All right, so we're going to start with the number talk. And essentially you are finding these problems mentally. I don't want to see any work. All right, I'm going to give you 3 minutes. If you finish before those 3 minutes, then please stand up. All right, have a seat, even if you are not done, that is okay. All right, so what did you get when you did 4.5 times 5? What'd you get? Emma?
180.
No. 4.5 times, sorry, times 4. My fault. Troy?
I got
18. Yes. And Troy, what was your strategy for solving this?
So I first did 4 times decimal 5, and it got 20. So then I did 4 times 4, that equals 16. Then I added the 2 and 20, and I got 18.
So you did 4 times 0.5, and you got 0.2, and then you did 4 times 4 and got 16, and then you added them together?
Yep.
Perfect. All right, what do you get when you do 4.5 times 8? Mikhail?
We got 36.
Okay, and what what did you do to get 36?
I multiplied the decimal 5 times 8 and I got.
I can't hear what you're saying, baby.
I multiplied the decimal 5 times 8 and I got 4. And then I multiplied the 8 times 4 and I got 32. And then I added the 32 plus 4.
Perfect. All right. What do we get then when we do 1/10 times 65? Jonathan,
6.5.
and what was your strategy?
I know that 1/10, to get 1/10, that we have to get divided by 10, so 65 divided by 10 is 65.
Okay. And so you did 65 divided by 10 equals 65. Perfect. All right. And then the last one is 2/10 times 65. What do we get for that one? 2/10 times 65. Ronnie.
0.65.
Nope, not 0.65. So be careful with this one because look at this one. This is 1/10 times 65. You got 6.5, right? So this is 2/10 times 65. So can we just multiply 6.5 times 2 and get our answer?
Oh,
Can we do that? Because I mean, technically, it's just 6.5 plus 6.5 at this point. Does that make sense to you guys?
Yeah.
Because this is just, it's the same except for it's just one more 1/10. So if you're doing 1/10 times 65, you get 6.5. Then you can do 2/10 times 65 and know that you're going to get 13 because you're just simply multiplying the 6.5 times 2. Okay? Just something to think about. Get your minds working a little bit this morning. I will let you guys know, a lot of times with these number talks, there's always a trick to the problems. Okay? Yes?
the fraction form of 6.5 work as well for 1/10 times 65.
Yeah. Yep. All right, let's slide down to the drink mix. All right, so since the other day we made a drink mix, which we did not, so don't be like, no, we didn't. By mixing 4 teaspoons of powdered drink mix for every cup of water. Here are 2 ways to represent multiple batches of this recipe. So here is a diagram. So this is the original, and then 2 batches. And then what do you think 3 batches would look like? Like if we had to add to this diagram, what do you think we're gonna add over here? Delilah.
The same thing, just it's gonna be 3. It's just gonna be another one, just it's gonna be the same. Like 4 squares and 1.
And then do I circle it?
Yeah.
Or do I circle all of them?
All of them.
Circle all of them. So essentially, this is one visual. So that's 1 batch, 2 batches, 3 batches. All right, the double number line is the same thing. So you have your drink mix. So if you have no teaspoons and no teaspoons of water, you have nothing. So your ratio is 0 to 0. But for our drink mix, for teaspoons, we mix 4 teaspoons to 1 cup of water. So our ratio is 4 to 1. All right? So this is technically times 1, correct? Does that make sense? So then this one is times 2, because if I do 4 times 2, I get 8. And 1 times 2, you get 2. So then what is 12? What's 12? What are we multiplying to get 12 and 3? Emma?
Times 3.
Times 3. And then what do we multiply to get 16 to 4? 4 times 4. All right, so what goes in this box? Right here and right here. What goes in that box? All right, Aiden?
For the top is 20 and the bottom will be 5.
Okay, and how did you figure that out?
Because 4 times 5 is 20 and 1 times 5 is 5.
Perfect. All right, so now that we kind of understand the double number line, like I said, it's just a visual for essentially equivalent ratios. So it says, how can we tell that 4 to 1 and 12 to 3 are equivalent ratios? So how do we know that these two are equivalent ratios? What did we do? This is very similar to, I believe, your cool down yesterday, right? Okay, Mikhail.
Because we can multiply 4 times, we can divide 12 by 4 and we get 3, and we can also divide 3 by 1 and we get 3.
No. There's a simpler, easier explanation as to why we know those two are equivalent. And guys, you have to divide or multiply by the same number for your both numbers. You can't divide by 1, like you can't divide by 2 and then divide by 3. Like make sure that you're either multiplying by the same number or dividing by the same number. Delilah.
They go into each other evenly.
Okay, they go into each other evenly, but there's something even more simple than that. Like there is a reason all of these are equivalent. All of them are equivalent. Why? If you don't know, look back in your notes because we legit wrote it down.
Because they can be multiplied, or they're multiplied by the same number to get.
You're almost there. You're on the right track. What do you mean the same number?
The product has been multiplied by
So let me help you out. When we filled out this double number line, what did we always multiply? What was the constant? So like here, what was the constant here?
1.
No. So I'm trying to do this without giving you an answer. So when we got 8 to 2, what did we multiply to get 8 to 2? Okay, I'm confusing you more. Zoe.
Would you multiply both sides by the same?
No, y'all, no.
1 to 4.
Yes. We always went back and multiplied by the what? The original
ratio.
The original ratio. You have to understand that. Because if we're multiplying 8 and 2 by 2, we're not going to get 12 to 3. We're going to get 16 to 4, right? So, understanding, you are always going back to the original ratio. We know that this is an equivalent ratio because we multiply this ratio to get that ratio. So you're always multiplying your original ratio. All right, slide up to number 2. It says, how are the representations the same? How are the representations different? So the same, how are they the same? What did we do to get every one of those sets of ratios on the ratio double number line thing? Troy?
We multiply
By what? Or what did we multiply every single time?
the ratio.
Which one? Troy, just look at what we just wrote. Like for number 1, what did we just write? So then that's why they're the same, because we multiplied the original ratio. If you learned nothing from today's lesson, hopefully you learned how to find equivalent ratios from the original ratio. Okay? Alright, how are they different? How are they different? Alright, and be mindful, we're talking about the diagram and the double number line. So how are they different? How are they different? No, how are they different?
One diagram, one number.
Right. One is a diagram. And one is a double number line. Alright, let's go ahead and move on. Number 3. How many teaspoons of drink mix should be used with 3 cups of water? Alright, all you have to do is look back at either your diagram or your double number line for this one. So I'll read it again. How many teaspoons of drink mix should be used with 3 cups of water? Any new friends today? Christiana, is your arm up? Hand up? Alright, what'd you get, Rick?
12.
Yes. So 12 teaspoons for 3 cups of water. And Christiana, how'd you figure that out? Gotta speak a little bit.
I looked back at the diagram.
Right, you look back at the diagram, because if you look at the diagram, all you have to do is count the small squares, right? Okay? Alright, number 4 says how many cups of water should be used with 16 teaspoons of drink mix? Alright, so this one you have to use which one? Which one do you have to use, William?
Number 1.
Okay, and then how many cups of water go with 16?
4.
And then number 5 says what number should go in the empty boxes on the double number line. What do these numbers mean? Alright, so we already filled that out, correct?
Yes.
So what 2 numbers go in the boxes that we filled out? Any new friends? Because we all did this, so it's just simply raising your hand and tell me what they are. Kylie.
20
So 22, 5. All right, and what do these numbers mean? So what does 20 mean? 20 what? Emmeline.
Drink mix.
Teaspoons?
Yeah.
And then what does the 5 mean, Emmeline?
Cups of water.
Perfect. All right, so I have a question. How do you feel about double number lines? Like, if we're looking at diagrams to double number lines, how do you feel? Like, would you like one better? Do you not like one better? You're kind of like, it's too early to tell still. What do you think? What do you guys think? Camden?
They're both easy to me.
Okay. Because one's just counting and one's like kind of goes in order, right? Okay. Delilah?
I think the diagram is more easy for me since I can visually see it, other than just numbers on the diagram.
Okay. Jonathan?
I think the table is more easier for me.
The table?
Like the 2 numbers and the 4 numbers.
Okay, well we're talking about these 2 right now. We'll talk about the table in a couple days.
I think the visual is very.
Okay. All right. So either one you could use. Okay? Isabel? What?
I feel like just seeing the numbers and just know
Okay. All right, so I have a question. For those of you who said the diagram is better, what happens when we have to make, let's say, 10 batches of this drink mix? What is your diagram going to look like?
it's gonna be huge.
It's going to be huge. All right? So diagrams are very nice because for the most part they're pretty simple to see, read, and understand. But sometimes they're just not feasible, are they? Like if you're dealing with really big numbers, having to draw 600 little teaspoons is gonna, yeah.
It's gonna take like the entire time to do that one question.
Right. So this is why we give you different strategies to use. If you are sold on diagrams, I'm okay with that. Like 100% I'm not gonna tell you you can't. Okay? But I just want you to understand, like sometimes it's certain strategies do not work just because there's so much to do for it. You had your hand raised, Kai? Are you sure? Okay. Alright, so let's slide over to 6.3. It says here's a diagram showing Elena's recipe for the light blue paint. So you guys remember this?
Yes.
Yeah.
Alright, so remember it's 2 cups to 6 tablespoons. Let's flip it over. So it says complete the doubled number line to show the amount of white paint and blue paint in different size batches of the light blue paint. So you have to label your number lines. So the top one, what do we want the top to represent? What do we want it to represent? Mila? White or blue? Blue? Alright, so blue tablespoons. Alright, and then obviously this is going to be the white cups. Alright, so what is our original ratio for tablespoons? And we can start with the very simplified one, or we can start with the one that we originally talked about. Mikael.
The top will be 3 and the bottom will be 2.
The top would be 3, the bottom would be 2. So this is the picture that we are looking at, right? The top is the white, the bottom is the blue. So you can either do it by 1 or you can do it by 2, however you want to start. So again, I'm going to ask, what number goes on top if blue tablespoons is what's on top? Ronnie.
1, 3, or 1, 3.
Guys, look at what you're doing. Blue tablespoons is on top. How many blue tablespoons do we have in one batch?
3.
All right, and then how many cups do we have next in one batch? All right, so from this point, and this is just times 1, I want you to fill out the rest of those tick marks. Stand up when you're done. Which means you weren't listening to anything I said. All right, so when we multiply this by 2, how many are going on top? Gemma.
6.
How many are going on the bottom?
2.
When I multiply this by 3, how many go on top? 9. How many go on the bottom?
3.
When I multiply this by 4,
12.
bottom,
4.
multiply by 5,
15.
bottom,
5.
and multiply by 6,
15.
and bottom. Perfect. All right. Now it says compare your double number line diagram with your partner. Discuss your thinking. If you need to revise it, go ahead. Do we need to change anything? Did everyone get this for the most part? Okay. Anybody need to change anything? All right. Number 3 says how many cups of white paint should Elena mix with 12 tablespoons of blue paint? So how do we go about figuring this out? So we're trying to find out how many cups of white paint for 12 tablespoons of blue paint. So just go up here and find, go ahead and circle which one would essentially give you your ratio for 12 tablespoons. All right, so Isaac, what did you circle? 12 to 4. So then, how many cups do we need? So 4 cups. And then how many batches does this make? No? And how did you figure that out? Well, not that you multiplied 4 by 3, but you're essentially multiplying by what? 4. So what if we multiplied by 2? How many batches would we have? 2. Okay, so just making sure you guys are understanding what the number that you're multiplying by to get your double number line. All right, number 4, it says how many tablespoons of blue paint should Elena mix with 6 cups of white paint? All right, so use the same strategy you did for 3 and find that 6 and circle it. Zoe, are you using an erasable pen in my class? Put it away and grab a pencil. You do not use any kind of pen whatsoever. Alright, so, which one are we circling? William?
6 to 8.
6 to 8.
6 to 18.
18, yes. And then, so how many tablespoons of blue paint do we need?
18.
18. And how many batches does that make?
6.
Make 6. And how do you know that?
Because if you divide,
Not divide.
multiply,
By. What's the number in the middle of our double number line?
6.
Right. So we multiplied by 6. So again, guys, please, 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 please be careful and understand this. Like, this is the number of batches that you have. Okay? That's what that multiply by whatever means. That's the number of batches that you are creating. Alright, number 5, it says use your double number line to find another amount of white paint and blue paint that would make the same shade of light blue paint. So what's another ratio that we created on this double number line that we haven't talked about yet? 9 to 3, right?
Yes.
So 9 to 3. What's another one? Someone else give me another one that we haven't talked about yet. Camden.
5 to 15.
5 to 15. All right, and then the last one, it says, how do you know that these mixtures would make the same shade of blue paint? So this goes back to the original question that we started with today for 6.2. That last question on the bottom of 6.2. How do we know all of these ratios are equivalent? How do we know? Troy?
Multiply by the original ratio.
Yes, sir. Okay. Questions about a double number line? Do you have to use a double number line? No. Now, I am going to let you know, your cool down today is obviously assessing you on a double number line because that was what our lesson was about today. I'm going to allow you to look at your lesson notes to help you with your cool down today if you need. So please do not glue this in yet so that you can see everything on your paper, including this example in your summary. Does that make sense? So please use your notes or your lesson notes to help you with this today if you need. All right, and also make sure that you're answering all of the questions. There are 3 questions on here, so I need you to completely and fully answer the questions and show your work so you get that credit. How many of you guys are done with Imagine Math? Okay, how many of you guys have makeup work that you would like to work on? Yes, I finished that, okay. If you haven't finished Lexia yet, you can work on Lexia. Sorry, I can't read, talk, and count. You just need to make sure that you are doing something that is going to be productive to your grade. Because remember, my grade closes on Friday. So make sure that you are working and doing what you're supposed to be doing. I need you to move up here so that I can see your iPad. All right, go ahead and get started with your cool down. Turn it in. I'll be passing out your cool downs from yesterday. Please make sure if you got a 50 or below that you resubmit it.